commonly referred to as the B-2. Its full name is the Northrop Grumman B-2 Spirit. This aircraft is among the most formidable assets in any nation's military arsenal. What sets it apart from other military aircraft is its primary role as a stealth bomber, with stealth capabilities being its foremost priority. But how does an aircraft that reaches a maximum speed of 0.95 Mach, close to the speed of sound, maintain such a high level of invisibility? In this exploration of the B-2 bomber, we will uncover its unmatched power. The B-2's design is striking. It is wider than it is long, boasting a wingspan of 52 meters, while its length measures only 21 meters. This unique configuration allows it to remain virtually undetected. A key factor in this stealth capability is its radar cross-section, which is only 0.1 square meters. In contrast, a typical cargo aircraft can have a radar cross-section of up to 100 square meters. The B-2's low-drag wing design not only minimizes its radar signature, but also enhances its operational range. It can cover distances exceeding 11,000 kilometers, about 6,900 miles, in a single flight, and can extend its range even further through mid-air refueling. The B-2 utilizes radar-absorbent materials, such as carbon graphite composites, which play a crucial role in reducing its infrared signature. These materials absorb radar waves that would typically detect the aircraft. Remarkably, approximately 80% of the B-2 is constructed from composite materials, which not only offer radar-absorbent properties, but are also incredibly strong and suitable for the aircraft's dynamic flight characteristics. The wings are designed with greater flexibility than those of conventional aircraft, allowing them to absorb aerodynamic stress more effectively, thus improving efficiency at high speeds. Using composite materials also contributes to the longevity of the B-2. Unlike metals and metal alloys, which tend to have shorter lifespans, composite materials can be engineered at a molecular level to enhance fatigue cycles, thereby extending the aircraft's operational life. However, as more countries recognize the B-2's capabilities, they have sought alternative methods for detecting stealth aircraft. Infrared systems can identify the heat emitted by an aircraft, not just from its engines, but also from the fuselage, which heats up due to air friction. To mitigate this, the B-2's engines are strategically positioned deep within the fuselage. In addition to its stealth features, the B-2 was designed to operate without reliance on GPS. Instead, it employs a combination of sensors, gyroscopes, and radar systems, allowing pilots to navigate based on visual landmarks. The inclusion of a GPS antenna could increase vulnerability to enemy detection. To address these challenges, significant investments were made to develop a new type of GPS known as M-code, which is more reliable, responsive, and exclusively for military use. This advancement marks a significant milestone in military navigation technology. While stealth is crucial, the B-2's primary mission is to deliver and deploy munitions against targets. With a wingspan that is approximately half the length of a football field, one might assume the B-2 has a substantial payload capacity. In fact, it can carry significantly more than one might expect. The two internal bays of the B-2 have an official capacity of 18 tons, but it is believed that the aircraft could accommodate even heavier loads if necessary. The B-2's arsenal includes up to 8,500-pound bombs, 36 750-pound bombs, 16 2,000-pound bombs, and 16 nuclear weapons, such as the B-61 or B-83. It can also carry a variety of satellite-guided missiles and penetrators. In June 2007, a decade after its initial development, the B-2 was awarded a contract to integrate the massive Ordnance Penetrator, MOP, a GPS-guided weapon weighing 5,300 pounds, designed to penetrate the most fortified enemy positions. Manufacturers assert that the B-2 Spirit is the most survivable aircraft in existence, combining long-range capabilities, stealth, and the capacity to carry an exceptionally heavy payload. However, this advanced technology comes at a steep price. Each B-2 is estimated to have cost $737 million in 1997, translating to about $1.2 billion in today's dollars. This figure is relatively modest compared to the overall development costs of the B-2, which, including testing and deployment, is approximately $2.13 billion per aircraft, around $3.5 billion today. Originally, 132 B-2s were commissioned, but this number was later reduced to 75 due to budgetary constraints. After the dissolution of the Soviet Union in the 1990s, only 20 B-2 bombers were acquired under the George H.W. Bush administration. A final 21st aircraft was authorized for conversion from a prototype, resulting in a total of 21 B-2s still in operation today. The U.S. plans to keep these aircraft until 2032, retiring them at over 30 years of age. Part of the investment involved acquiring an old Ford plant in Pico Rivera, California, which required extensive rebuilding to accommodate the B-2's impressive wingspan. The early stages of the B-2 program were shrouded in secrecy. Staff members often worked out of uniform to avoid drawing attention, and they were routinely subjected to polygraph tests. Additionally, procurement efforts were conducted through front companies to maintain confidentiality regarding the assembly of the B-2. However, acquiring such an advanced aircraft is only one aspect. Maintaining the B-2 is another challenge altogether. It is estimated that each hour of flight requires 119 hours of maintenance, double that of the B-1B and B-52 bombers. In 2010, the cost of each flight hour was reported to be around $135,000 to the U.S. taxpayer. While we've explored the B-2's impressive stealth and staggering firepower, what is it like to be inside one? Pilots undergo daily training to ensure they can competently operate the aircraft whenever needed. The cockpit features 2 seats, occupied by the trainee and the instructor, both of whom have access to the control stick at all times. The instructor can take control at any moment, following protocol that requires the pilot relinquishing control to announce, "I have the aircraft," to which the other responds, "Roger, you have the aircraft." Like many commercial aircraft, the B-2 is equipped with autopilot, which helps maintain altitude and course. However, space inside the cockpit is limited, accommodating only the 2 seats and a narrow passage behind them, which provides just enough room for a blow-up mattress. There is no dedicated bedroom or refrigerator. Pilots are expected to bring non-perishable food items for their missions. Despite the high-tech cockpit, the restroom facilities are quite basic, consisting of a stainless steel bowl located in the space behind the seats, completely uncovered. In addition to flying such a large aircraft, pilots must remain vigilant against both aerial threats and potential digital attacks. They also need to manage weapons systems and monitor critical information related to hydraulics, electronics, and environmental conditions across 8 screens that dominate the cockpit. Pilots have reported that the most significant challenge lies in managing all these tasks simultaneously while flying at nearly the speed of sound. Regardless of one's views on military operations, it is undeniable that the B-2 bomber represents a pinnacle of advanced engineering. It combines remarkable speed and firepower with the ability to operate in ultimate stealth. This aircraft is not just a testament to technological prowess, but also a reflection of the complexities involved in modern military aviation. The B-2 Spirit stands as an extraordinary achievement, capable of executing missions that can alter the course of conflicts, all while maintaining a low profile in the skies.